Hi, my name is John, and welcome to another edition of Statistics Tell a Story. I want to follow up on something I did previously with hypothesis testing, and I mentioned something very important in the world of hypothesis testing, which is p-values, and how I believe, and there are others in that camp that believe, that p-values are distorted, so to speak, the way they are presented. At least the probability of p-values. Let's first define a hypothesis test. A hypothesis test is where we conduct a test and we try to prove something, okay? Generally, they're set up with something that's called an H sub 0, which is a null hypothesis, and H sub 1, which is an alternative hypothesis. So for example, H sub 0 might be an experimental blood pressure medication has no effect on blood pressure. Okay? H sub 1 is that it does have an effect. Okay? And very often we make an analogy to a court trial. Court trial, right? H sub 0 would be the accused is innocent. H sub 1 would be the accused is guilty. So innocence is usually no difference, or in this case, no effect. Okay? For H sub 0. Okay. What is a type 1 error? Type 1 error is when we reject HO when HO is true. So in words, it would be rejecting that the blood pressure medication has no effect when HO is true, when it does not have an effect. Or another way of saying that is, it's believing that it has an effect when in reality it does not have an effect. Okay? This is standard definition in basic statistics. Okay? Now, we can also state the probability of a type 1 error, right? So if a type 1 error is rejecting HO when HO is true, the probability of a type 1 error is the probability of rejecting HO when HO is true. Okay? Now, so we said that we're going to test blood pressure medication. Okay? Here is the crux of what I'm getting at. Let's say that there are 1,000, pretend that there are 1,000 instances in which we're going to do something like this, okay? So for example, we have 1,000 different hospitals and maybe there's 1,000 different blood pressure medications, okay? Even though they're each kind of doing their own separate one, I'm emphasizing this to point out kind of this big picture scenario. So, we have one hospital and they're saying, you know what, I think this blood pressure medication might work, et cetera, right? Now, here's what's very important, is to take an educated guess as to how effective that might be. And this is kind of like the big black box, so to speak, that is very difficult. And all we can do is take an educated guess, and I'll get to why this is important here in a second. But let's say that we surmise it should be effective 30% of the time, okay? And maybe that's based on past history. Maybe that's based on gut feel, right? Whatever it might be. Okay. So we're gonna test 1,000 instances. I'm gonna emphasize the word instance because it's like 1,000 different trials, so to speak, that are completely different. And of those 1,000 different trials at these 1,000 different hospitals, right? 1,000 different, ways that this medication has been put together, we surmise it's going to be effective 300 times, okay? Okay, so I'm going to branch off here, and again, educated guess. It's going to be effective 300 times. That means it's not going to be effective 700 times, okay? Well, when it's effective, another word that I'll briefly discuss is the power of a test. And that's when you find in favor of H1 when H1 is true. Actually, so let's just say the power is 80%, meaning when it's effective, you're going to find it effective 80% of the time. So when it's effective, you're going to find it effective 240 out of 300 times. This is represented by the variable beta. Beta is much more complicated than alpha, which is a type 1 error. And for the most part, beta, which we're not going to get into, I don't want to call it an educated guess, but it's kind of along those lines. But we're going to surmise that the power is 80%, so we're going to find it effective 240 out of the 300 times it's really effective, which means we're going to find it not effective 60 times, okay? Now, when it's not effective, we're going to still find it effective. And this is where you get back to, if you remember your critical region, I'm not going to get into that. You can always ask a question on this, but we're going to find it effective just by chance, assuming that our alpha is 5% of the time, which is 35 times, which means we're going to find it not effective 665 times. Okay, what's the probability of a type 1 error? Remember, type 1 error is rejecting HO when HO is true. I emphasize the word when, right? So when HO is true is here. So the probability of a type 1 error is indeed 35 over 700, which is 5%. Textbooks are fine up to now, okay? Here's the problem. When we find it effective, we really should be saying something to the effect of, we made a mistake this many times. Where do I get this? Because when we find it effective, the denominator is no longer 1,000 or even 700. The denominator is now this plus this. When we find it effective, we found it effective 240 times here, 35 times here, total of 275 times. We found it effective 275 times. We made a mistake 35 of those times. What's 35 divided by 275? It's approximately 13% of the time. That's basically what we should be saying we never do. Why? Well, again, there's no easy solution. Why don't we say that? Because remember my assumption that we said that it's going to work 30% of the time? That was an educated guess at best. We didn't know. That's why we were testing it. But in my opinion, the way we do it now to give that probability of a type 1 error, while it's true the way we've defined type 1 error, it's very misleading. Again, there's no easy way around it, but to me, I think it would be better. Not that textbooks are going to all of a sudden change, but who knows, maybe eventually we'll morph over to that, something to that effect. But we should be taking educated guesses as to the percent of the times it's effective, maybe take an educated guess as to the power of a test, and then we can make a conclusion as to how often we are wrong when we find effectiveness. If you have any questions, feel free to post them, make any comments. I hope you hit the subscribe button, and we'll see you next time on Statistics Tell a Story. Thank you.